least we'll pick it up from here and see what happens. Okay? All right, so, Miss Liz, how are the numbers going on the top? Huh? They're going up by 1. Very good, Liz. Nice work. So this is going up by 1 every time. So we are good on that note, right? Miss Haley, how about the bottom?
The first one's going up by 4, and then the second one's going up by 8.
Oh, and then the last one's going up by?
8.
More than 8. Anybody know what the last one goes up by? 16. Okay. Now, on the first example that we had that the app so rudely shut down on us, we noticed that the top numbers were all 1s, like Liz noticed on this one. And we noticed the bottom numbers on the first one were all 2s, so that's why it was linear. This one, Haley noticed it's not going up by the same number every time in the bottom, is it? On this particular thing, when it goes up by 4 and then by 8 and then by 16, that's not linear. That's exponential. So if you notice, think of it this way. Watch this. They don't show this in your book, but this is how it works. What's the difference between here and here? If I times it by 2, do I get 8?
Yes.
If I times 8 by 2, do I get 16?
Yes.
I'm timesing, aren't I? So if that's the case, then you would answer that it's an exponential. Okay? It's linear if all the numbers are the same, like the top ones are all the same and the bottom ones are all the same. It's exponential if like the top ones are the same, but the bottoms go up by multiples. Okay, not the same number every time in the bottom. All right? What do you think about the first example? You guys okay with that? Okay. Then, the second thing that it has, or example number 2, says y equals -2, 5 to the x power, and it says x equals 3. And what it wants you to do is it wants you to evaluate that. Now, the word evaluate, can anybody define what they think evaluate means? If I said I was going to evaluate you, what would that mean? Make sure you're doing it right. Okay? And for this particular problem, it's kind of the same thing. When I'm asking you to evaluate, I'm going to make sure you do it right. And by doing it right means I want you to plug in the number and see what comes out. Okay? That's what you got to do for this one. It's giving you the x. You have to plug in the x and tell me what the y is. That's it. So have you ever plugged in numbers into an equation before? If I gave you a number and an equation, have you ever done that before where you plugged something in and see what you got? That's what you're doing. So for this particular thing, you've got y equals -2, parentheses, 5 to the third. So I'm putting a 3 in for x, and let's see what we get. Now, what this is not -2 times 5 times 3. That's not the case. Remember, when you have 5 to the third, that's saying 5 times 5 times 5 times -2. So what number spits out at you if you put -2 times 5 times 5 times 5? That's the answer. I need someone with a calculator that's willing to punch that in for us. -250. So my answer for this one, when it asks you to evaluate, we're just trying to figure out what the number is after we plug it in. So, as Miss Alyssa said, we got -250. Okay, is everybody okay with that? How that came up? Okay, let's do the next one. Y equals 3, parentheses, 0.5 to the negative deuce. Now, The thing is, when you have a negative exponent, do you remember on the first part of the chapter where we got rid of the negative exponent by putting it to the bottom? We don't need to do that on this problem. We just need to type it in my calculator and see what happens. So I'm going to take 3 parentheses, 0.5, close it, caret, because caret means the exponent, to the negative 2, and see what comes out. So in the problem it says y equals 3.5 to the x, and then it says x equals negative 2. So all I did was I put negative 2 in for x. Now using a calculator, what number comes out?
12.
12. And again, how you type it, I would type 3 parentheses, 0.5, close it, caret, negative 2, and hit enter. And that should come out as a 12. Yes, Miss Haley?
So you're just putting 2 in for both x's with them?
There's only one x.
Oh,
The second x in the back is just telling you x equals this.
and then you're just timing
You're just putting it in and see what happens.
it?
Hmm? What do you think about example 2? Not too bad? Okay, so let's check to see if this one works. I got x and I got y, so this is like the first ones. 0, a 1, a 2, a 3. 8, 4, 2, 1. So on the top, Julio, how do they change on the top? They go up by 1. Nice work. This goes up by 1 every time. Caleb, on the bottom, do they all like add or subtract by the same number every time? No, they don't, do they? So if they don't do that, remember for these problems, it's asking you, is this linear or is this exponential? So if it's not the same number every time, then it's probably going to not be a linear, right? For a linear to happen, it needs to be the same number every time. So from here to here, how did it go from 8 to 4? Some people might say subtract 4. But what if I said divide by 2? Is 8 divided by 2 4?
Yeah.
Yeah. So think about dividing it by 2. Now if I go from 4 to 2, if I divide by 2, isn't it the same? And then what about the next one? 2 to 1?
Yeah.
Yeah. If it's dividing or multiplying, you guys, then it's not linear. It's, what's the other option?
Divide.
If it's not linear, then it's exponential.
Okay.
Okay, then the next one. X, wise guy, 0, 1, a 2, a 3. Every time. Okay. Zach, on the top. How are my numbers going on the top?
And my order is like 1, 2, 3.
They're in order, right? How are they increasing? By what number every time?
Up by 1.
Nice start. They're going up by 1 every time. So plus 1, plus 1, plus 1. So we're good that way.
They're going down.
Huh?
They're going down by 1 on the bottom.
Oh, they're going down by 1 on the bottom? All right, so minus 1, minus 1, minus 1. Perfect job. So if you notice, on the first ones, the one that Zach said for the top, we were increasing by 1 every time. So that's good. And on the bottom, we're subtracting 1 by 1 every time. That's also good. If you're adding and subtracting by the same number every time, that's linear. If you're multiplying or dividing by the same number, then that's going to be an exponential. So what would this one be then? Linear.
Linear.
Yep. So this answer down here for this one would be linear. Okay, is everybody okay with those?
Mm-hmm.
All right. Y equals 2, parentheses 9 to the x, and then in the directions it says evaluate when x equals negative 2 and when x equals 1/2. Ooh, they give you a fraction. Those little rascals. So for this, remember this is like one of the ones we did here just recently, right after the table ones. This is where we plug them in and see what happens. So on the first one, I got y equals 2, parentheses, 9, caret negative 2. So when I type that into my calculator device, what number comes out for me?
0.024691.
What are you talking about?
I put it in.
Ah, what came out?
Came out as a decimal.
Okay, what was it again? Tell me.
0.024691358.
All right. Now, my guess is this. As Alyssa got that as her decimal, holy cow. My guess is it probably meant it as a fraction. And here's what you would do. If you remember what we did in section 6.1. Do you remember how the negative exponents went to the bottom?
Yes.
That would be a 2 over 9 squared. What's 9 squared? What's 9 times 9?
81.
81. So your big fraction that you gave me was probably the same as 2 over 81. So what I want you to do, Alyssa, because I know you have your calculator out, take 2 divided by 81 and tell me what number comes out.
Same thing.
Is it 0.024690138? Yeah. Okay. So the thing is, by doing that, I'm just explaining or just showing they're the same. You can have either one, and I'd be perfectly fine with that. Okay?
Mm-hmm.
So then, for the next one, I got to put in a negative, or not a negative, a positive 1/2. And I'm going to put that in red so that we have it on the same screen. Okay? So I have y equals 2, 9 to the 1/2 power. Now, if you recall from section 6.1 or maybe in 6.2, the 2 stays here, but 9 to the 1/2 power is the same as me saying the square root of 9. What's the square root of 9?
81.
No, that's the square of 9. What's the square root of 9? So what times what gives me 9?
3 times 3.
Remember, if we have that like that, where it's 2 and then we have 3 squared, if the numbers match, remember the number in the crack?
Mm-hmm.
If the numbers match, they cancel out. So that leaves me with 2 times 3. What's 2 times 3?
6.
6. So my answer is 6 for the second one. Okay, what do you think? Can you handle that?
Mm-hmm.
All right. So for today, that's as far as I want to go into 6.3. I don't want to give you all of it and overwhelm you too much. I just want to shorten it up a little bit. So that's as far as we're going to go for today on 6.3. There's more, but I want to make sure you don't get too overwhelmed. Okay? So for the first part, basically what they're going to do is they're going to say, is this a exponential function, yes or no? Okay? And then after that, what they're going to do, and they're going to have tables for you. And then the last parts are going to say evaluate. Okay? I'm going to adjust the assignment a little bit, because the first ones are a little bit more confusing than the other ones. Okay? But just so that you guys know, on the first part of the assignment, it's going to give you a table and says, is this linear or exponential? Then the second part is going to be where you evaluate it, where you plug the number in and see what you get. Okay?
Mm-hmm.
And if you're looking on big ideas, I'm going to adjust it real quick, so just wait. I'm going to adjust the assignment. Okay? So